Okay, so let's go back to the moving train. And let's imagine that we have someone on the train and they will emit light. They will turn a flashlight on, or equivalently, we can think of light being emitted in both directions. From the perspective of the individual on the train, light will travel this way, hit both walls of the train at the same time. Okay, so from the perspective of the observer on the train, light hits the two walls of the train at the same time, and we want to see this on the space-time diagram. But we're going to imagine two separate trains. So let's imagine that we have a train in xt. So here is xt, and this is a green train. So let's make a green train. So at t equals 0, this is one wall of the train, and this is the other wall of the train. And the train is just sitting here from the perspective of the observer that's measuring x and t. So it's just a stationary train. And so this wall of the train just goes straight up on the space-time diagram. And so does this one. Just goes up straight like that. It's like suddenly this train appears in space, but so be it. That's the way it is. And if we look at light, so light is emitted at t equals 0. We emit light from here, from the middle of the train, and of course it goes at 45-degree angles. So it goes like that and like that. And so we can see that this and this, they make a horizontal line. That's a line of simultaneity from the perspective of the xt observer or individual. Okay, so simultaneity involves horizontal lines. Now let's think of, so this is the green train that's just stationary from this perspective. Let's make a red train. So we have a red train that, so they're starting together, and then one starts to move, let's say, to the left. So we have one end of the train going like that. And then the other end of the train, which is the back end of the train. And now I have to make this parallel to that red line. So that looks fairly decent. Okay, so that's the motion on the space-time diagram of the front end of the train and the back end of this red train. And now, at the same moment that the green observer sends a light signal in both directions, so does the red observer who's standing on the red train. But it's the same on the space-time diagram. It's just the yellow line. But we can see that first light hits the back end of the train here. So that is right there. And we have to go a little bit further for the light to hit the front end, because the front end is moving away from light. So I have to continue the light beam. Let's see if I can do this right. Continue at the same angle, and there it is, hits the front end. And so I'm going to make a little dash here, indicating the event when light hits the front end of the red train. And But this is a line of simultaneity. From the perspective of the red observer, these two events occur at the same time. That's a line that tilts in the direction of the spatial axis, x bar, whereas this is in the direction of t bar, right? So we can see that this slice of simultaneity for the red observer is different from a green slice of simultaneity for the green observer. And so we confirm from a different perspective that simultaneity depends on the observer.